Hello everyone, the humble math tutor here. Welcome to part 2 of my exploration of this integral. In part 1 we learned how to deal when at least one of m or n were odd. Here in part 2 we find out how to proceed if both m and n are even. You'll have to have at the ready these double angle formulas. So the cos of 2x, you will recall, is 1 minus 2 sine squared x. If you take the time to solve this for sine squared x, you get sine squared x equals 1 minus the cos of 2x over 2. Also, please recall the cos of 2x is 2 cos squared x minus 1. And if you take the time to solve this for cos squared x, you get cos squared x is 1 plus cos 2x over 2. You'll need these when solving integrals of the type we're discussing today. Let's investigate this integral to explore. Sine to the 4th x times cos squared x dx. Both exponents are even, so we need this method today. The idea is to use these formulas here to break this down and continue to rewrite it and break it down so that it is simply a sum of linear trig ratios with no exponents on them, which can easily be anti-differentiated. So let's get started. Sine squared x is 1 minus cos 2x over 2. So sine to the 4th of x will be the square of this formula. Let's put it in. So this guy becomes 1 minus the cos of 2x over 2 squared. Now cos squared x is exactly this, so I'll put that in next. And that will be 1 plus the cos of 2x over 2. And of course, dx was always there. Okay, before we proceed, notice that this 2 will be squared and there's a 2 here. I could get rid of those denominators immediately and just put them out front as 1/8 of the integral of 1 minus the cos of 2x squared times 1 plus cos 2x dx. Continuously looking to simplify, and it minimizes the chance of mechanical mistake later. Okay, I'm going to expand this and then multiply by that. So it's going to get quite lengthy now, the integrand. This will be 1/8 times this, and if I multiply this out, I'm going to get 1 minus 2 copies of cos 2x plus cos squared of 2x, and this guy was always there, 1 plus cos 2x dx. Very good. So far, so good. Well, look at this. I've got a squared where a 4th used to be, 4th exponent. So remember what I said, we're trying to knock down the exponents, so the exponents will always be 1. And we have this sum or difference of several trig ratios with the maximum exponent will be 1, and it'll be easy to anti-differentiate. So let's continue here. I'm going to multiply this trinomial by this binomial now, and that gives me 1/8 of the integral of. So I'm going to run this 1 through against these 3 terms. Then I'm going to run the cos 2x through against these 3 terms and add everything up. So let's see how that goes. So if I run this 1 through, I've got 1 minus 2 copies of the cos of 2x, and 1 times this is plus cos squared 2x. Being mindful that this is going to be very lengthy, so I'm trying to write a little smaller to make it all fit in. Now I run the cos 2x through against these 3 terms, so I get plus cos 2x minus 2 cos squared 2x, and then this times this gives me cos cubed of 2x, and I just fit my dx in over there. So all is good so far. There are some like terms. So I have 1/8 times 1 And then this and this are like terms, so that's minus cos 2x. This and this are like terms, so it's minus cos squared 2x. This has no like terms with him, so that's going to be cos cubed 2x dx. Alrighty. Now what I'm going to do is just observe what I have. This is easy to anti-differentiate. I won't mess with that. It's fine. That's easy to anti-differentiate. I'll just leave that. This guy here, he could be simplified, because what I'm going to do is I'm going to take that 2x there, and I'm going to go back and observe this formula right here, and I'm going to put a 2x in there. So I have cos squared 2x, and that will be 1 plus cos of 4x over 2. So this guy is going to be replaced with 1 plus cos 4x over 2. This is going to be anti-differentiated on its own with a substitution. Let's get started. Continue on here. So what I'm going to do is break this down into two integrals. So I've got 1/8 of the integral of 1 minus, now cos 2x, not going to change that, easy to anti-differentiate. And this, I said, was going to be 1 plus cos 4x over 2. I'm going to leave that there, and I'm going to add to that the integral of this term. So I'm going to put that underneath, and that's going to be 1/8 of the integral of cos cubed 2x dx. Just broken down our integral into two separate integrals. Okay, let's start to simplify. I have a 1 here, and you'll see that I do have a minus 1/2 pending. It's going to be coming in, when this minus sign distributes through this. So 1 minus 1/2 is going to give us a 1/2. So on the next page, I will have here I am here. So on the next page, I'm going to have 1 and a minus 1/2 is going to give us just a 1/2. And I still have this minus cos 2x here. And then I'm going to have a minus sign coming through to this guy. It'd be minus 1/2 of cos 4x dx. And then underneath that, I have this integral to be dealt with. What I'm going to do is siphon off one of these three cos 2x's and put it to the right. So here we go. That will give us plus 1/8 of the integral of cos squared 2x times cos 2x times dx. Okay. Well, this looks pretty easy to anti-differentiate, these three terms. I may as well go ahead and deal with this. So this continues to be 1/8 times, and I'll do the antiderivative now. The antiderivative of 1/2 is 1/2 x. The antiderivative of cos 2x will be 1/2 sine 2x. And the antiderivative of cos 4x, that's going to be 1/4 sine 4x, isn't it? But with the 1/2 in front, it'll become 1/8 sine 4x. Plus 1/8 of the progress of this integral here. The progress of this integral here, I'm going to write this cos squared 2x as 1 minus sine squared 2x. I'm going to leave the cos 2x the same, and now I'm going to use substitution on this. So if I let u be sine 2x, this will be a multiple of the derivative, won't it? So over here, I'm just going to say let u take on the value of sine 2x. So du is going to be 2 cos 2x dx. And so therefore, du by 2 will be cos 2x dx. And that's what we need, because that's what appears here. This will replace this because of this equality. So everything now becomes, if I continue on, what I'm going to do is run the 1/8 through against each of these three terms and simplify this portion of our answer, and then I'll continue to work on the integral at the same time. So that will give us, at this stage, 1/16 of x minus 1/16 of sine 2x minus 1 over 64 sine of 4x plus 1/8 of our integral, which is emerging here, right? 1/8 of 1 minus u squared times du over 2, where u takes on the role of sine 2x. Doing well so far here. This is great. Which is equal to, and I got to keep recopying this, unfortunately, to give proper form to the answer, and that's going to be 1/16 x minus 1/16 sine 2x minus 1 over 64 sine 4x. The 2 and the 8 combine to make a 1/16, right? So that's going to be plus 1/16 of, and I take the antiderivative of these guys now, and that's going to be u minus 1/3 u cubed, plus c, where c is a real constant of integration. And now I'm just going to put the sine 2x back in for these guys. And that'll give us a final answer. I'll see if I can squeeze it on the last line here. Equals 1/16 x minus 1 over 16 sine 2x minus 1 over 64 sine 4x, and then I'm going to run the 1/16 in through against the u when I put the sine 2x back in place of the u. So that's going to be plus 1/16 sine 2x minus 1 over 48 sine cubed 2x. I see I have some cancellation taking plus c, by the way. And I'm not going to finish this on this line, am I? Have a look. We have some like terms, don't we? These terms are the opposite of one another, so they'll cancel out completely, won't they? And then I'll finish up on the next page after all. So that'll give us the following. That equals 1/16 x minus 1 over 64 sine of 4x minus 1 over 48 sine cubed of 2x plus c. Thank you very much. If you enjoyed this video, please like, subscribe, and share. If you have suggestions for topics for future videos, please leave those in the comments below.